Hello, my name is Mark Larive. I'm a strategic marketing manager at Xenics, and today I will present you the high performance InGaAs camera and what are their use in semiconductors inspection. So first I will make an overview of Xenics, who we are, where we are, and what we cover, and then we will dive inside the semiconductor market. What are the needs? Why the InGaAs and the shortwave can be used, and what Xenics can offer, and what is the additional value for the semiconductors inspection. So first of all, at Xenics, we are an infrared solution provider with a leading edge product, and we have a very strong and long knowledge in technology. And the goal of Xenics is to really offer affordable innovation. So that means in order to do that, we listen to the market and to the customers, and we are driven by the application. We are a small company, but small enough that means a lot of flexibility, but we are big enough to offer a strong and in-depth support to our customer. That's a very important point, especially for this kind of activity in semiconductors inspection. And finally, we can say that we turn, in fact, all our expertise and our technology into business value for the customers. So where are we? So we are located in Belgium, headquartered in Leuven. It's close to Brussels. We also have a subsidiary in Singapore to cover the Far East market, and also in the US, East Coast and West Coast to cover the US market and the North America market in general. What do we cover? Let's say all about infrared. A strong focus in short wave, but we're also proposing mid wave, some solution, and some solution also in long wave and cool long wave. We are vertically integrated, especially for short waves. That means we offer from the sensor itself, just the sensor, to the core, that means sensor with the electronic, and to the global camera. And we offer that with the line scan 1D or the area scan 2D cameras. Our competencies, technical competencies, everything about sensors and cameras, especially for short wave. We master the material technology, and very important, we master the readout circuit design, which is at the heart of the capability of the cameras. So it's very important. We do not rely on external readout circuit manufacturer. We do it by ourselves, so that the sensor and the camera are really dedicated to the application for which we design. For sure, we also design the electronic linked to the sensor for the core and the camera with the mechanic. And we also are expert in software, either embedded software inside the camera or the interface software for the user. We also have lots of skills in image enhancements to provide nice picture, and in radiometry, so that our cameras can give really be thermographic. So let's go now to semiconductors. Our understanding in semiconductors is the following. First, there is an adoption, a massive adoption of the new technologies. This leads to really more and more complex chips, and also an increase of volume, because more of applications are demanding and are asking for these new chips. So in order to answer that, there is a need to increase the throughput and to increase the yield of the production. And then there is a strong demand in the quality inspection enhancement, and also in process control. So why shortwave and why InGaAs in semiconductors inspection? That's the answer. In fact, the silicon is transparent between 1 micron and 1.7 micron. So that's what you see on this slide. When you start to cross the 1 micron, InGaAs sensor, which are sensitive in these wavelengths, start to see through the silicon, and then you can see what is inside the chip. So you can detect whether there are some defect, whether things are, let's say, the things are normal, or whether there is a drift in anything in the conception and the manufacturing, let's say. So in Xenics, we offer a wide range of cameras and sensors, from the line scan to the 2D arrays, sensitive in shortwave, based on InGaAs technology, which is very sensitive, between 0.9 micron and 1.7 micron. And it comes from the linear standard 512 or 1024 up to 2048 pixel, with the fastest camera that you can find on the market at 256 kilohertz. And in the 2D, we offer QVGA or VGA, that means 645-12 pixel cameras, running up to 1700 hertz full frame, which is again the fastest on the market. So which product for which kind of application? Inline inspection, process monitoring, we can propose high definition, high speed linear array for push broom application up to 2K, or 2D arrays for step and cell detection. And for offline, then again, line scan with 2K and 2D array up to the VGA format. So an example of line scan in semiconductor. So this is used for defect inspection, micro cracks detection with photoluminescence, inspection of the wafer or of the ingots. And that's what you can see. You can see the small cracks or the defect in the ingots. So here we can propose the Lynx and the Manx, which is the fastest line scan camera. It gives at the customer level higher throughput and better defect detection. Another kind of example with a 2D is to observe exactly what is inside the sensor, the chip. Here we made an experiment with a Wildcat, which is a 645-12 camera. And we have the ability to see the different layer, in fact, either with bottom illumination only, or with a combination with bottom plus top illumination. And that's what you see here. With the bottom illumination only on the left, first of all, you see that you can detect very small features, as low as 2 micron, probably even less than that. And okay, that's what you see when you illuminate only from the bottom. And when you add some top illumination, you see additional features which are revealed. So that means it's an upper level. So playing on this, you can see different layers inside the semiconductor. Another example of what can be seen with a Wildcat, a very small feature inside with a typical opening in metal layer, as small as 3 by 9 micron. And a real example on the field, this is for crack detection. And you can see on the right the picture obtained with the visible camera, and on the left with the infrared camera. And on the visible camera, you can see only top surface particles, but nothing inside. And with a short wave on the left, you can see that typically on the left part of the chip, you have some small crack that you can reveal only with shortwave cameras. And that's what you want to reveal, and that's why you are using shortwave. So this is on this is picture obtained with a Bobcat 640. So what's next? In fact, we are expanding our portfolio, And in line scan, we propose already the links up to 40 kilohertz line rate, up to 2048 pixel. This is used for crack inspection or alignment. But we also have the very high-speed Manx camera up to 256 kilohertz with square or rectangular pixel, and this is used also for crack inspection with a higher throughput, but also for void detection, for cleaning inspection, for thickness measurement. And for the 2D array, then we offer from the QVGA with a large dynamic, or for the high-speed QVGA, or even for the full VGA format, again for crack inspection and alignment. And if we go for advanced detection with void detection, cleaning, and thickness measurement, then you can use the Wildcat low noise or the very high-speed camera, such as the Cheetah. And then very soon, we will introduce the ASIC-GA format with the Wildcat 1280. That is the real high resolution, which will be very well suited for the crack inspection and the alignment. So I thank you very much for your attention, and you can contact me for any question at mark.larive@xenics.com. Thank you very much.